These are notes on a type of mixture called solutions, and it's really going to introduce you to a lot of vocabulary so that when I say certain things, you know what I'm talking about. So they're not so much concepts right now as words and definitions. So first let's look at how we know kind of so far how to categorize matter. Okay, so first we know that we have matter, and that's anything that has mass and volume. And anything that's not matter is energy. So these terms shouldn't be new to you. We've been talking about this all year long. So right, matter is, as I'm looking around my house, my cell phone, a cup with some water in it, even the air around me, my laptop, the mouse I'm using. And then energy is everything that does not have mass or volume. So any of the light that's coming out of the lights on my ceiling or the lights on my computer screen. I can feel some heat coming out of my laptop. So those are all energy. So in these notes, we are specifically focusing on matter. And what we know so far is that with matter, you can have pure substances and mixtures. And remember, pure substances are things that are made of just one type of thing. Mixtures are made of more than one type of thing. So within pure substances, you can have elements. So here, this is the sulfur powder that, if you remember, you burned earlier this year, or you actually melted it earlier this year. It's that yellow powder, and it gave off that kind of rotten egg smell. You could also, though, have pure compounds. So you could have salt that's just salt. So that's sodium and chlorine, and they're bonded together, meaning they're stuck together like Legos. There's baking soda, and that's actually sodium and hydrogen and carbon and oxygen. So those are 4 different elements, and those again are stuck together like Legos to make this stuff we call baking soda. Both of these, salt and baking soda, have scientific names, so you could call salt sodium chloride, and you could see sodium and chlorine are on the periodic table. You could call baking soda sodium bicarbonate, and sodium's on the periodic table. You then kind of have to know what bicarbonate is, and that's hydrogen, carbon, and oxygen. It kind of has the word carbon in it. And so those are all pure. Then on the other hand, we have mixtures that are made of more than one substance. So we have 2 kinds. We have kinds where you can't see the different substances in it. So like, here's a beaker of water with food coloring. You can't look in that and see the particles of food coloring. It all looks to be the same thing, even though it's a mixture. And then on the other hand, you have mixtures where you can see the different parts. So this one is sand and water, and you can obviously see the sand there. And even if I mixed it up, you could still probably see the sand. And one big difference between pure and mixtures is that you can separate mixtures, but you can't separate pure substances. So it makes sense that you can't separate sulfur because it's just an element. But you also can't separate like the sodium from the chlorine in salt, or the sodium from the hydrogen and the carbon and the oxygen in baking soda. You can't separate those. As we've been saying, they're stuck together like Legos. So these are 2 terms that we use when we're talking about mixtures. So this is all having to do with mixtures now. One is soluble. Soluble means one substance dissolves in another. And when that happens, you can't see the different parts. So going back to here, this stuff here would have substances that are soluble. Whereas the sand in water, where you can see the different parts, that's called insoluble, when one substance does not dissolve in another substance. So let's now talk specifically about those mixtures where you cannot see the different parts. So here we're talking about the blue food coloring in water. So mixtures where you cannot see the different parts has a special name, and that name is a solution. And so let's look at this solution here. Okay, so the blue is water and the white are particles of sugar that are dissolved in the water. And if you've ever put sugar in water and then you stirred it up, as long as you don't put too much sugar in, all of the sugar dissolves. So you can't see the different parts. You can't see particles of sugar. We'll talk in a few minutes about what it means when you can see the particles of sugar. But for right now, this whole thing is water, and then these white particles are particles of sugar. So again, a little more vocabulary. In this solution, we have two different parts. We have the water and we have the sugar, and those have names. So the solvent is the thing that there is the most of. So in the solution, whatever you have the most of is your solvent. The solute is everything else. So looking at this picture, what do you think the solvent is and what do you think the solute is? So the solvent is the water because there's mostly water. The sugar is the solute. And you can actually have more than one solute. If I let me put some little red dots in here. Let's say this is now some salt that I've dissolved. Then I would have two solutes. I would have sugar and salt. But I only have one solvent because there's only the most of one thing. Okay? Now, there's two more vocabulary words. One is unsaturated. Unsaturated is when you can still dissolve more solute. So let's take our sugar water. If I'm dissolving sugar and I put in another spoonful and it all dissolves, then that water wasn't saturated yet. It's unsaturated. But if it's saturated, it means I can't dissolve any more solute. So think about a time when you've made like hot cocoa or something where you're dissolving like a powder into a liquid, and sometimes when you get to the bottom you see almost like some of the powder still, it hasn't all dissolved. That means your liquid was saturated. It couldn't dissolve anymore, and so it all just fell to the bottom because it is, solids generally are more dense than liquids, so they fall to the bottom. One thing I want to mention that's not in here as a slide is that solutions don't have to be liquid. So in this case it's liquid, but air is a mixture. It has nitrogen and it has oxygen and it has other gases too. So that's a solution where you can't see the different parts. If you're looking at the air, you can't tell which one is nitrogen and which one is oxygen. Solids can be solutions also. So if you think about bronze, right? We saw the video with the bronze bell. Those were two solids. There were some particles of copper and some particles of tin, and you couldn't tell them apart. So solutions don't have to be liquidy. They could be solid, they could be gas. So that's a really good thing to write down as well. All right, have a good day.